Physicists have long theorized that there is a subatomic building block that exists.
Excitement and relief as the Large Hadron Collider subsystems whir back into action.
We're standing here at the entrance of the tunnel that leads to the Super-Amio Candide detector. It's about 2,000 m down this tunnel to the left. One feels the stare of 11,000 giant orange eyes. Neutrino oscillation showed that neutrinos must have some tiny but non-zero mass. Did you know that one of the world's most celebrated science institutions has just made a discovery that could completely alter our understanding of reality? CERN has activated a neutrino quantum field, and leading experts are warning about potentially dangerous consequences. This isn't just another scientific experiment. It's a leap into uncharted territory where the known laws of physics may be pushed to their very limits. For decades, CERN has been synonymous with breakthroughs that have redefined our comprehension of the universe. Now, with this groundbreaking experiment, the center known for discovering the Higgs boson is testing boundaries that many thought were only theoretical. Imagine being able to control and manipulate a field of neutrinos, particles so elusive that billions pass through you every second without you ever noticing. That's exactly what the scientists at CERN have done. In the next few minutes, we'll explore what a neutrino quantum field is, how CERN managed to activate it, and why some of the world's top physicists are expressing serious concerns. This isn't merely about pushing scientific frontiers. It's about confronting the potential risks that come with such monumental discoveries. If you've ever been fascinated by the mysteries of the universe and the cutting edge of modern science, then you're about to be taken on an extraordinary journey into the unknown. CERN, the renowned European Laboratory for Particle Physics, has just announced a breakthrough that has stunned the scientific community. In a bold experiment, researchers have successfully activated a neutrino quantum field, an achievement that sounds like it belongs in the realm of science fiction. But this is real, and it has immediate and profound implications. So what does it mean to activate a neutrino quantum field? In simple terms, the scientists have managed to create a controlled environment where the normally elusive neutrinos, particles that hardly interact with anything, are manipulated in a way that allows their quantum properties to be studied more directly. Neutrinos are known for being incredibly difficult to detect, yet they are fundamental to our understanding of the cosmos. By isolating and stimulating these particles, CERN's team has opened a door to a deep understanding of quantum mechanics, one that could reveal new physics beyond our current theories. However, the excitement is mixed with caution. Many experts have raised concerns that this unprecedented experiment might trigger unforeseen reactions within the delicate balance of quantum fields. Some worry that the artificial activation of a neutrino field could set off a chain reaction of unpredictable events. These scientists argue that while the potential for discovery is immense, the risk might be equally significant, possibly challenging the established principles that have guided physics for decades. I want you to consider this: if we start manipulating the fundamental components of our universe, how do we know what ripple effects might follow? What could begin as a controlled experiment could potentially escalate into something with far-reaching consequences. Share your thoughts in the comments below. I'd love to hear what you think about the risks and rewards of such daring scientific pursuits. This story is developing as we speak. And while CERN's achievement is undoubtedly historic, it also serves as a stark reminder of the responsibilities that come with pushing the boundaries of knowledge. Let's continue to explore the details behind this groundbreaking experiment. To fully grasp the magnitude of what has just occurred, it's essential to understand a bit about CERN and the mysterious nature of neutrinos. CERN has long been at the forefront of particle physics, consistently delivering discoveries that have reshaped modern science. It's a place where theories are challenged and the secrets of the universe are gradually revealed through meticulous research and daring experimentation. Neutrinos are among the most enigmatic particles known to science. They are almost massless, rarely interact with matter, and are so pervasive that they constantly stream through everything around us. Despite their abundance, neutrinos have remained shrouded in mystery because their feeble interactions make them extraordinarily difficult to study. They pass through entire planets, including Earth, with barely any trace, leaving scientists to rely on indirect measurements to learn about their behavior. Quantum fields, on the other hand, are the foundational constructs that govern how particles behave and interact. Every particle we know is essentially an excitation or disturbance in an underlying quantum field. When we talk about activating a neutrino quantum field, we refer to creating conditions in which these disturbances can be observed and manipulated intentionally. This experiment is not about producing neutrinos out of thin air, but about engaging directly with the field that defines their behavior. CERN's latest achievement is particularly remarkable because it brings together these two areas of cutting-edge research. By activating a neutrino quantum field, researchers are stepping into a realm that was once purely theoretical, offering a glimpse into phenomena that may eventually redefine our understanding of the natural world. It's a bold move that promises to unlock new avenues of discovery, even as it raises critical questions about safety and unforeseen consequences. The science behind these fields is complex, but the core idea is simple. By studying the interactions within these quantum fields, scientists hope to uncover clues about forces and particles that have eluded detection until now. This could lead to revolutionary advancements in physics and technology, potentially opening the door to discoveries that could change the way we interact with the world. As soon as the news of the neutrino quantum field activation broke, the response from the scientific community was swift and filled with both excitement and trepidation. Many respected physicists have expressed concerns over the potential dangers of tampering with such a fundamental aspect of the universe. Their worries are rooted in the idea that while this experiment might illuminate hidden corners of quantum physics, it could also unleash consequences that we are ill-equipped to manage. One major concern is that the controlled activation of a neutrino field might lead to a cascade of interactions that defy current scientific predictions. In the world of quantum physics, even small changes can have monumental effects. If the neutrino field were to behave unexpectedly, it might disrupt the balance of forces that hold our universe together. This chain reaction, although purely hypothetical at this stage, has prompted some experts to caution against overzealous experimentation. Furthermore, there is an ongoing debate about the ethical implications of such experiments. The pursuit of knowledge is vital, but it must be balanced against the potential risks. Some scientists argue that pushing the limits of our understanding is essential for progress, while others warn that interfering with the fundamental forces of nature could have irreversible effects. The possibility that an experiment like this might lead to unforeseen disruptions in the fabric of reality has sparked intense discussion among researchers, policymakers, and the public alike. These concerns are not just speculative. They are based on rigorous theoretical models and past experiences in high-energy physics. History has shown that groundbreaking discoveries often come with challenges that are only understood in hindsight. The current experiment at CERN is a clear example of this dynamic. It holds the promise of unveiling new physics, but it also demands that we carefully consider the potential costs. The tension in the scientific community is palpable. On one hand, the lure of discovering entirely new phenomena is irresistible. On the other hand, the risk of inadvertently upsetting the delicate equilibrium of the universe is a burden that weighs heavily on the minds of even the most optimistic researchers. As we delve deeper into the implications of this experiment, it becomes clear that the debate is far from over. Now, before we dive even deeper into the science behind this experiment, let's take a moment to consider the most mind-blowing possibilities. Imagine a scenario where the activation of this neutrino quantum field doesn't just reveal new particles, but also opens up pathways to phenomena that challenge everything we know about time, space, and matter. Some leading theorists have suggested that such experiments might eventually lead to insights that could revolutionize technology, energy production, and even our understanding of the cosmos. If you think that's wild, just wait until you hear about the next phase of research. There's already talk among top physicists about the potential for follow-up experiments that could amplify these effects, or even harness them for practical applications. The very idea that we might one day manipulate the building blocks of the universe is as thrilling as it is daunting. So keep your curiosity alive and get ready for more jaw-dropping revelations as we continue to explore this frontier of science. Remember, every major breakthrough starts with a bold idea that challenges the status quo. Let's now get into some of the technical details, the kind that make this experiment both a marvel of modern science and a subject of heated debate. Quantum field theory is a framework that underpins our understanding of how the universe operates at its most fundamental level. In this theory, particles are not seen as isolated objects but rather as disturbances or excitations in fields that permeate every inch of space. When scientists refer to a neutrino quantum field, they're talking about the field associated with neutrinos, those ghostly particles that are nearly massless and interact very weakly with ordinary matter. In the experiment conducted at CERN, researchers have managed to isolate this neutrino field and stimulate it using finely tuned energy inputs. The process involves creating conditions where the field's inherent fluctuations become observable. This is a monumental task because neutrinos are notorious for their elusiveness. They rarely interact with the detectors designed to capture them. By carefully calibrating the energy levels and environmental factors, the CERN team was able to activate the field, making the normally hidden quantum excitations accessible for study. What makes this achievement so remarkable is that it allows scientists to study phenomena that were previously only the subject of theoretical models. The controlled activation means that researchers can now observe interactions in real time, measure subtle changes in the field, and compare the results with predictions made by the standard model of particle physics. This experiment has the potential to either confirm long-held theories or force us to re-examine our understanding of how the universe is structured at its most basic level. The implications of this research are profound. If the observed behavior of the neutrino quantum field deviates from what current theories predict, it could signal the presence of new forces or particles that have never been detected before. Such a discovery would not only expand our scientific horizons, but might also have practical application in the future, potentially influencing technologies that rely on quantum mechanics. Yet with all this promise comes a degree of uncertainty. The very act of stimulating a quantum field is fraught with challenges. Even small variations in the experimental setup can lead to unexpected results. Some scientists have raised the possibility that this activation could trigger reactions that are difficult to predict, possibly upsetting the delicate balance of the quantum world. These are not idle concerns. Quantum systems are known for their sensitivity to initial conditions, and the experiment at CERN is operating right at the edge of what we currently understand. In summary, while the technical details of the experiment are intricate and may seem overwhelming at times, the core idea remains both simple and revolutionary. By activating a neutrino quantum field, CERN is taking a monumental step towards unraveling mysteries that have puzzled physicists for decades. This deep dive into quantum field theory not only highlights the sheer ambition of the experiment, but also underscores the potential risks that come with venturing into unknown scientific territory.